Okay, in this video we talk about finding the greatest common factor, or abbreviated as the GCF. So before we can talk about finding it, we need to understand what it is. So we begin with the definition. The GCF of two or more expressions is the largest expression that will divide into each evenly. So in other words, without a remainder. Now we're going to talk about GCF for both variables and numbers, but we'll begin first with numbers because I think it's easier to connect to that. For example, if we were looking for the GCF of 8 and 20, we'd say, well, that's 4. Right, because the biggest number, they're both numbers, so the only thing it's going to divide into them are numbers. The biggest number that would go into both would be 4. Now there's other numbers that go into 8 and 20, but it has to be able to go into both, and we want the biggest, the largest expression. As another example, consider the GCF of 40 and 32. Well, 4 is into both 40 and 32, but it's not the biggest. 8 is bigger, so 8 is therefore the GCF of 40 and 32, and there's nothing bigger than 8 that would work for both. Now our next example, GCF of 64 and 44, is a little bit harder. One thing you can do is you can kind of guess and start dividing stuff out, and maybe you get the biggest, maybe you don't. Well, there's actually a way that we can approach it to make sure that we do get the biggest thing that will divide into each. The way we do that is we begin by writing down our two numbers, and we're going to divide, except it's kind of going to be upside down division, or sometimes when I teach it in arithmetic I call it birthday cake division, because it kind of looks like a birthday cake. And we say, let's find something that goes into both of them. In this case, well, 2. Or maybe you might say, hey, I know 4 goes into both. Well, then pick 4. Well, we're just going to divide it out, and then we're going to look at what's left. In this case, 22 and 32. And we're going to say to ourselves, well, hey, we can take something out of that. And we just keep repeating this process until we get down to a pair of numbers that we can't divide anything else out of. And then once we've done that, we can take the stuff that we've divided out to get the GCF. So it turns out here in this case as well, the GCF is 4. Now to find the GCF for variables, it's actually quite a bit easier. To see how GCF with variables works, we give the following condition. If the variable happens to occur in each expression, then we'll take the smallest power that occurs. Otherwise, we leave it out. To see why we have to take the smallest power, consider x squared and x cubed. If you tried to pick x cubed as your GCF, when you try to divide that into x squared, you'd have x squared over x cubed. And if you're having trouble seeing this, you might want to write it down. When you simplify, you'd have 1 over x. You're left with a fraction, so it didn't divide evenly. And the reason we leave it out, if it doesn't show up in each one, well, we can see that with this GCF of x squared, y, and x cubed. See, the problem here is, if you tried to include the y, well, it would work for x squared y. That would divide out, but with the x cubed, the y would still be in the bottom and you'd be left with a fraction again. And so that's why it has to occur in each thing, and then if so, we take the smallest power. Otherwise, it gets left out. So that's how we find the GCF with variables. In the next video, we'll talk about using the GCF to do some factoring.